folks, today's lesson, we kind of shift gears a little bit. So there's two parts to chapter 4. There's lesson 1, which is a little bit different, right? We did that box problem. We explored what happens when you make a box and the max volume and stuff. And that's part of this unit. All right, so that's like 1/2. And then the next 6 more lessons, so 4-2 all the way through 4-7, those lessons encompass kind of the other half. Okay, and so we're going to start by looking at like big formulas, like polynomials that are degree 4, degree 5, degree 6. We're actually going to have you end up graphing them. And you're just like, it's not that bad. It's actually one of the nicer units in my opinion, if you get these things down as we go. Now the other thing I'll throw out there is you really shouldn't have any homework when you leave in chapter 4. Like you might have one problem to do or something, but I give you a lot of time for homework in this chapter. So like if you use it, you really won't have anything to deal with, okay? So I'm going to skip your homework to get the lesson done, and then we're going to go back and I'll help you with your homework, all right? So I mentioned to a few, you might have heard the chapter 3 test overall was very good. We'll talk more about it on Thursday, but I was very actually happy grading. Normally, grading the chapter 3 test, I am not mentally the happiest, but I was pretty happy. Like I was going through, I was like, nice. You're wrong, but that was still pretty dang good. So it was good. All right. So grades are in IC, so you can see them. I did post your quarter grade without that though, so it did not affect your quarter grade, but it does affect you obviously going forward. So we're gonna talk about that more on Thursday. But here we go. So on your packet, you can see it says, what happens if I have a cubic and it's a positive cubic? And I'm going to change the premise of that question. We're going to kind of shift it around. Actually, don't need you to write anything down for a minute. What I want you to think about instead is, what the heck happens if I have a degree 3 or degree 4 or degree 5, degree 6, degree 7? Do you think they do anything that's similar? Because that's where we're going to base this off. We're going to see if there's a pattern. And so I'm actually going to start with some Desmos. We're just going to take a look at it. There we go. And I actually have all the evens clicked right now. So I have 4, I have 6, I have 8, 10. And you can see like on this graph, the stuff in the middle is a little bit different. But they all basically do the same thing. They all go up, right? The two ends of it go up. Now, that's if A is positive. If I change that, and if I make it negative, what do you think is going to happen? They go down, yeah. So they go like that. And so I'll slide up. So that's the even. What do you think the odds do? Do you think they do the same thing? They're going to be different. And so I'll unselect these. And I'm going to flip this quick. So if they're positive, I have one going down and one going up. Like if I go to the left, it goes down. If I go to the right, it goes up. What I always think about, like in my head, if I'm trying to remember this, is I just think about a line. If I have a positive sloped line, it goes like that. It starts low and it goes high. So that's something to think about. If I flip that, if I have a negative sloped line, I start high and I go down low. Okay? Now, I always kind of joke around with people about, hey, this is your like, we had homecoming already, but this is like your homecoming dance routine. Like Lane's out there like this. Cubic. And then he flips it, and he's a negative cubic. And then Laney's out there like, woo! Positive quadratic, quartic. I know. You can say like, okay, boomer. I'm not that old, but I would accept that one. So, regardless, that's what we're going to explore today. So we're going to fill out some stuff on your sheet really quick, and then we're going to fill that chart out on the bottom. And I would put a star by that chart. Because when I say we're graphing these things eventually, we will find the middle stuff, but I always start here. I always start with this chart. So I'm going to get rid of this. Get back to our smart notes. And so instead of degree 3, I want you to think degree 3, degree 5, degree 7, so on and so forth. It's always going to be the same. We'll fill this in our chart later. But if I have a positive A, it looks like this. And I am purposefully not doing anything in the middle because I don't care about the middle. We call that like the guts of the graph. I don't care about that. I only care about the outsides of the graph. Now, if I look at negative A looks like this. It starts up top and goes down. I already talked about that. So that's the odds. So then when I go to a quartic, degree 4, I'm really talking about the evens. And so the even functions, I'll slide down, look like this. They either both go up together or they both go down together. So evens are nice because actually when we start working through stuff today, evens always have the same answer. I find one answer, I found both. If it's an odd function, if I find one answer, the answer always has, the next one has to be the opposite. So there's little things in our brain that we want to like always be attuned to. I'm going to skip this. And I'm going to jump down to that table. Is there any questions though before I do that? All right, we got this table. Now, like I said, I want you to put a star here because you're going to use this a lot. It's going to show up all the time. So if we have an even power, I'll just put some here as examples. But I can ask you about x to the 100,000s or the millions. And it's still going to be the same as an x squared when we talk about end behavior, which is kind of crazy. But so if it's positive, it's like this. And if it is negative, it's just going down. The odd powers, we're talking like x cubed, x to the 65th, x to the 1,000,001 or 100,001, doesn't matter. Any odd power with a positive coefficient looks like this. And any odd power that has a negative coefficient looks like that. So this table basically sums up our entire lesson. So today, when I ask you questions, I want to see you moving your arms and showing me what does this look like. Okay? Or some people just point, that's fine too. But you gotta start doing it. And on your test, some of you are gonna be like this. No, maybe not. Lane, you're gonna do it just for me. There's always one, right? Oh, sorry. Alright. Anyways, so now we start. So we got some fancy notation up here. I'm gonna explain what it is. I'm just gonna dive down. And all that paragraph is saying up above is that mathematicians are lazy. We don't want to write a big, long sentence. Instead, we want to just write something very short and to the point. So we use this notation. But what does this mean? It means as x goes to the right, y goes, and then there's a blank. That's what it means. We're going to answer that in a minute. The bottom piece says basically the same thing, but instead of to the right, it's saying to the left. Otherwise, it is all saying the same thing. So I have this little chart over here even. I have positive infinity, which is going up. I have positive infinity, which is going to the right. I have negative infinity, which is going down. And I have negative infinity to the left. So there's other ways of thinking about this too. As x goes to the right, it's becoming a bigger and bigger number. As it goes to the left, it's becoming a smaller and smaller number, even though it's becoming a really big negative number. It's kind of a weird concept. But let's talk about this. X cubed. Point the arrows to me. What are we looking at? Positive x cubed. Yeah, all right. Positive x cubed looks like that. And remember, if it's positive, I could draw a line like that. That's positive, right? So positive x cubed. I'm going to get rid of that green line because I don't actually want it there. As I'm going to the right, where is this arrow going? Up. What is up on that graph? Infinity, positive infinity. So my answer is just infinity. I'm always surprised by the infinity symbols that I get during this unit. There's some unique ones. It's just a sideways 8, folks. Just draw that. Okay, as x goes to the left, where's that arrow going? Down, which mathematically is
Negative infinity.
negative infinity. Boom. So negative x cubed looks like what? Yeah, all right. So I got negative x cubed. So this one, as I go to the right, where am I going? Down. So I'm going negative infinity. And as I go to the right, I'm going to positive infinity. Good to go to the next? Yeah.
Is the first one going to the right? But for the number 2,
This one?
Yeah.
Okay.
For the first answer, is it x goes to the right?
Yes.
You get negative?
Yes. So this is positive infinity. So positives to the right or up. Now when it's talking about x, it has to be going to the right. Does that make sense? We pretty much always ask it in that order too. That's like pretty standard. As you go to the right, what happens as you go to the left? That's a follow. But that's good. You got to be watching out for those symbols. All right. Moving on then. Quartic. What are we doing? Yeah, we're going up. Okay. It is even and it is positive. So we are going up. So it's like this. What is my answer for both of them? Positive infinity. Yeah. If I go to the right, it's going up. If I go to the left, it's going up. Okay? So again, this is right. This is left. That's up. This is also up. Okay, negative quartic. Nothing too crazy. It's just going down. So I'm going to put my arrows there. What's my solution for both of them? Negative infinity. Yeah, for both of them. What questions do we got? All right, flip the page. Is that 3 positive or negative?
Positive.
Positive. Oh, if it helps you, put a plus sign. Now, what degree is this? So what's the exponent? That's another name for it. It's degree 6. So what are they doing? Are they both going up or both going down? They're both going up because it is positive and it is even. So it's going like this. So just like 2 problems ago, these are both going to be positive infinity because as I go to the right, this arrow goes up. As I go to the left, this arrow goes up. So both of them go to infinity. This next one, now we got negative 3. So the number is just negative. Okay, so nothing crazy there. But sometimes I'll even cross it off and just put negative right there. Because that's all I care about. I don't care about the 3. Even or odd? It's odd. So what's it doing? Yeah, it's doing this. Okay, so I'm going to draw that. So as we go to the right, what do I get? Negative infinity. As I go to the left, I'll get positive infinity. So a couple quick things for you. If I'm looking at an even answer here, and I have a positive and a negative, okay, I need to change that. All right, okay, because they always go together. If I'm looking at an odd function and I have two that are the same, again, I did something wrong. So please be diligent with that. Any questions so far? Yeah. This? You care if it's positive or negative. That's about it. For us, okay? So you care if it's positive or negative. What it does is it just takes the graph. So if my graph is this, well, actually, this is degree 6. So my graph is like this. That 3 just makes it go steeper. So it just makes it shoot up that much quicker. But the end behavior is always the same. It's still going up. Here's the extension. These numbers are blacked out. And that's because if I have negative x to the 5th, I have negative x to the 5th plus 13x cubed minus 33x squared, or I have negative x to the 5th plus 1000x to the 4th, that's a 4, minus 31x cubed. They all have the same end behavior. They all do the same thing in the end. So all I care about is not what follows. I only care about this number right there, and I care about the sign in front of it. Okay? So this right here is a negative degree 5, so it goes like this. And then I'll answer it just like I did on the last problem. The last problem, we had the same thing. Okay, slightly different looking, but it was the same. So I got, as I go to the right, I go down. And as I go to the left, I'm going up. Questions? Yep. And there's one little trick with that. I don't want to necessarily say the first. I'll say the first if it's in standard form. But if I have this, I actually care about this one. I care about the biggest exponent, okay? But we typically write things in standard form, so normally that is the first one. It's a good question. Any other questions?